Everyone. Today we will be presenting our project on hydrogen generation from biomass using gasification and triboelectric nanogenerator. This is our project 990A final presentation for this semester. We are a group of two people, myself Abhinandan Rai and Ishan Sheth. Our supervisor is Dr. Lihang Zhang and our instructor is Professor Dr. Jamil. And to begin with, I'll start the introduction with my friend Ishan.
Cover several topics for from introduction. The introduction would cover our aim, what was our vision, what we thought we would do, and how we dealt with the problems. Then we are gonna focus how we took the hydrogen production as our main topic and why we chose biomass gasification as our feedstock and the process for the work. Then we are going to talk about how triboelectric nanogenerator works and how did we install it in our simulation. Then we are going to talk about hydrogen generation from biomass gasification and triboelectric nanogenerator. Then we are going to focus on equations and chemical reactions involved in the following simulation. Then then we are going to focus on the simulation model and the layout diagrams, and then we are gonna conclude the presentation. Century or in this modern world, we are the technology is more now much more focused on producing green energy or say renewable energy rather than uh, focusing on production of energy or electricity from non-renewable sources, as we have become more concerned about environment and the depletion of non-renewable energy sources like coal and other minerals. Our major focus, we have shifted our focus to produce energy from renewable energy sources, and we have we have developed a lot. But what is the next step we are gonna take in modern world? So from last few years, there has been a major focus on production of hydrogen electricity from hydrogen, or let's say replacing the electricity with hydrogen. Now hydrogen, we have classified hydrogen into several other names, several other types like blue hydrogen, gray hydrogen, and green hydrogen. And there are much more which will take a lot of time to discuss, but our main focus is production of green hydrogen. So what is the green hydrogen? Green hydrogen is basically production of hydrogen from from renewable energy sources where there is less carbon emission, and there is a lot more efficiency and lot more efficiently, and which is a lot more cost efficient and efficient in the market. And so let's focus on that. So, so hydrogen generation from biomass has a several other ways to product for the production. So like green hydrogen can be produced by several processes like combustion, pyrolysis, liquefaction, gasification, and many more. But we narrowed it down to pyrolysis or gasification, and after a long debate and a long research, we decided to focus more on gasification as it is much more efficient, and more favorable, as it has more hydrogen content compared to pyrolysis. Although it is a complex process, but let's focus on what we call production of hydrogen using biomass gasification. Let's talk about our feedstock, biomass. Why did we select biomass and not the other resources, other feedstocks like natural gas, elec- ele- renewable energy sources like the process of electrolysis or anything? But why did we choose biomass? Because biomass is a renewable energy sources first. Second, it is a carbon neutral or low carbon emissions. Let me focus more on that. Biomass can be carbon neutral is a carbon neutral source of hydrogen which can be used in processes like gasification. During the growth of biomass, plants absorb carbon dioxide from atmosphere, and when the biomass is used for hydrogen production, the carbon released during the process is reabsorbed by the new plants in the closed carbon cycle. However, it is essential to ensure that biomass production process and transportation are done sustainably by maintaining the carbon neutral aspect. The the other reason for biomass is the availability. Biomass is available more more available easily rather than any other sources, and it is biomass is something which can benefit the locals. And when keeping the supply chain in the mind, biomass is a good source or for the earth feedstock. So let's focus how does the biomass gasification works. So, biomass gasification is a process which involves converting organic materials such as wood chips, agricultural waste, even municipal solid waste into gas mixture called syngas. And agri and I'll tell you one thing, one major source, our garden waste. It's also a part of biomass, which I saw the reactions and we decided to take biomass. That's the other reason. Then let's focus back on topic. This mixture contains hydrogen, carbon monoxide, and other gases that can be separated and used for various purposes, including production of hydrogen. So, how does the biomass process start? How does the gasification process starts? First, so during the process, we convert solid biomass into mixture of gases including hydrogen, carbon monoxide, methane and other hydrocarbons. The biomass is fed into a gasifier where it reacts with a controlled amount of oxygen or steam at high temperatures. Then we go for syngas generation where gasification reactions produce syngas which contains hydrogen along with other gases. The composition of syngas varies based on gasification conditions and feedstocks used. Let's focus on the other major device which we added to a simulation called triboelectric nanogenerator. So first of all, what's a triboelectric nanogenerator? So it is basically a device used to is an energy harvesting device which the device that can generate electricity by utilizing the contact and separation of different materials leading into transfer charges. Does it work? The basic principle behind turboelectric ni- triboelectric nanogenerator is the tribal effect, which occurs when two materials with different electron affinates into contact and then separate, causing transfer of electrons between the materials. This results in a buildup of charge on each material, which can be harnessed into create an electrical current. In a triboelectric nanogenerator, this process is repeated many times per second as a result of mechanical motion such as movement of a finger or vibration of a machine. As two materials repeatedly come into contact and separate, they generate a small electric current that can be captured and stored for later use. They have the potential to be used in a wide range of applications, from powering a small electronic devices to generating electricity from ocean waves or even human movements. From biomass gasification and triboelectric nanogenerator. So it begins when the conversion of solid biomass into gaseous fuel, which is then used to power a triboelectric nanogenerator. It is a basic integration which we put on mechanical devices to extract the power rather than just leaving it in the heat. So leaving it as a heat process. So it's better to extract the mechanical energy produced from the movement of the machines. So this is where the triboelectric nanogenerator works. Second, the process starts with the gasification of biomass, which produces a syngas consisting of carbon monoxide, hydrogen, and other gases. This syngas is then cooled and cleaned before it enters the triboelectric nanogenerator, where it is used to produce electricity through mechanical motion, as I explained, because there there are chemical reactions involved. So thermoelectric nanogenerator does not directly affect the gasification process or the chemical reaction, whether it just uses the movement of the machines or the devices which which work in the chemical in the gasification process and use their movements as the source of its own energy, of its own source of energy, and then produces electricity through them. So so the electricity generated by triboelectric nanogenerator is used to power an electrolyzer which splits water into hydrogen and oxygen. So here it is, the hydrogen and oxygen. Hydrogen which we are going to extract and use it for further use, or let's say hydrogen is our main product, and oxygen which we can release in the whole in the environment, or rather purify it and again use it in the chemical reactions, which is a much more efficient way. The resulting hydrogen is then stored or used as fuel for various applications. And now storage issue, which we did not, which is the part. So next comes the storage part. But we let's focus more.
Gasification process involves several chemical reactions that transform solid biomass into syngas, a mixture of hydrogen, carbon monoxide, and other gases. The reactions can be broadly classified into three stages: drying and pyrolysis, then combustion, and finally reduction. The specific reactions depend on the type of biomass, gasifier design, and operating conditions. The key chemical reactions involved are drying and pyrolysis. During this stage, the biomass is heated in the presence of a limited supply of oxygen, leading to the release of volatile compounds. The primary reactions are, so the first one is drying, biomass drying, which is like C6H10O5, that is also known as cellulose, with heat. So it gives 6C plus 5H2O. Then the thermal decomposition is same one. Then we go to the second step, which is combustion of volatile compounds. So it's in this combustion zone, some of the released volatile compounds react with limited oxygen available to produce heat for the subsequent gasification reactions. The main reactions include C plus O2, that is CO2, and that's it for this slide. Gasification reactions. The steam H2O or carbon dioxide reacts with the remaining char and volatile compounds to produce syngas. The key reaction is the first one, which is a water gas shift reaction, that is carbon monoxide plus water gives carbon dioxide and hydrogen. Then there is a methane reforming process, which involves carbon monoxide plus hydrogen that gives methane and water. And finally, there is a Bourdieu reaction, which gives carbon plus carbon dioxide, which is carbon monoxide. And then there's a water gas shift reaction, which gives carbon monoxide plus hydrogen gives carbon dioxide and the remaining final R product hydrogen. This is a layer diagram which starts basically with our feedstock, that is biomass, and that enters into the chamber where the steam reforming process starts. Then it enters into a shift conversion where there's a high temperature shift and then the low temperature shift. It gradually goes to the process condensate where it is further processed, and then finally CO2 is removed, which is a CO2 removal process. Then the methanation process goes, and finally we get our product hydrogen.